All right, we got the Unit 1 test review here. First couple questions are going to ask us if the following points are collinear. So we're going to look here at the picture. First one we got here is VXZ. Since those all lie on the same line, we will say those are collinear there. So you're looking for the same line, and then there is one special case that we'll talk about here in a second. Next, you have Z. Where is the Z? There it is, U, and then Y. Now it looks like they could make a straight line there, but those don't have a line going through it necessarily, so we're going to say no, those are not collinear there. Here, let me put yes and no's. Okay, next one here, you got, let's erase. We got W, V, and then Y right there. Now those are all on lines, but they're not on the same line. So we'll put no on that one. All right, and then the final one here, you have W and then V. And this one's kind of a trick one. This one's actually yes. And that's always because 2 points are always collinear, no matter what. You could go and get a line that goes through both of those at the same time. So that's kind of the tricky one right there. Okay. Next, we're going to look here at coplanar. Some of these have some weird cases, and I might even add in just a couple of other examples here just to make sure we kind of cover all the different situations you can see. But let's start out with here. You got V, X, U, and Z. That appears to be on this plane right here. They didn't name that plane, but they're all in that one plane, so those will be coplanar. So I'll put yes there on that one. Okay. Next, moving on here to number 6, you have W, X, Y, and then V right there. Now this one is kind of a special case one right here. I'll put a star next to it. This one is coplanar, even though you do have a point below the plane that you have and a point above. And here's the deal. You could go and get a plane that actually goes through all of these points here at the same time. Kind of, think about if it was kind of like a vertical plane, like an imaginary plane, and it has to do with these 3 points here being on the same line. Since those 3 points are all on the same line, you could get the edge of a plane to hit right there and then extend out this way. So that one's kind of a weird one right there. I don't think you see a ton of examples like that, but that one is technically yes. I think this next one is kind of similar here. You're going to have V, X, Z, and then W. And for that same argument, you could get a plane that hits all of those right there. And it's because these 3 here are on the same line right there. So that one would be yes as well. Okay. Next, we got Z. Where are we? Z, U, Y, Y and W. Now, 2 of them are on one plane, and then one of them is off of the plane above it, and then one of them is down below the plane. So there's not one single flat surface that you could get through all of those. So that one is going to be no. Okay, and then one other example I want to add, it's kind of similar to 4 up there at the top, so I don't know, let's call this 8.5. If I ever give you 3 points, for example, let's say I give you X, W, and then Z. If I give you 3 points, that will always be coplanar no matter what. And that's kind of similar to the reason why 2 points are always collinear. Any 3 points, you could always get a plane to hit 3 points, no matter what angle or direction those are facing. So with that one right there, I'm going to say yes, and I'm going to add myself a note. 3 points are always coplanar. Okay, so make sure you add that in there. That'll be good to study with there. Okay, next you got a couple of true or false questions determining if these things are the same or not. So, just true or false statements here. So you got X, V, and X, Y are opposite rays. Here's X, V, and then X, Y. I agree, those are opposite rays. I would say yes because they make a straight line. They have the same endpoint and opposite directions. And what I mean by opposite is totally opposite. They make it straight line together, basically. If I were to choose XW there, those are different directions, but not opposite directions. So that one was specific to that case there. Okay, next you have WX is the same thing as XW. Okay, so WX and XW, I would say yes, because those are the same segment there. You know, they're asking is segment WX congruent to segment XW, since they have the same endpoints on that one. It's the same endpoints, just, you know, written in a different order. Okay, and you can do that with lines, and you can do that with segments, not with rays. Rays have a direction to them. All right, next we're dealing with lines. We have ZX. There's line ZX right there. And line ZX extends forever, so it's really referring to this entire line. And then they're asking about WZ, which from W to Z is right here. That is still the same line. Since lines go forever, that's technically yes. So I'd say yes. I would say lines extend forever. So those are the same line right there. Really, when you name a line, you need any 2 points on that line and then use your line symbol. So as long as you use 2 of those 3 points, you're going to be good. Let's look here at these rays. So you have YX and then ray YV. And the rays, they need the same endpoint and same direction. This one will also be yes. We'll say yes. First of all, need the same endpoint and the direction. Same endpoint and same direction. Okay, so a lot of truths here so far. You know, they won't all necessarily be true, and then maybe 1 or 2 false. It just really depends on what they're giving you. So what do we got here? We got the segment VY. Here's VY. Is that the same as the segment VX right here? And since those have different endpoints right there, I'm going to say no. No, because they have different endpoints. Okay, and that'll be it there on that. All right, moving along here, this last section on this page here is asking you to find AC. This is asking the distance. And for distance, remember in your notes, we do whatever the letters are, we subtract them, and then you do absolute value, which means make it positive. Okay, so if I'm finding from A to C, and you can subtract this in any order you want. You can go -4 minus 3, or you can go 3 minus -4. And based off the order I got it right here, it's -7, but then the absolute value of -7 is +7. Okay, and you would have gotten the same thing if you did 3 minus -4, because 3 minus -4, the double negative will change it to addition. That would get you +7, and the absolute of +7 is 7 right there. Now, I'm not going to write all that out every single time for each problem. I just wanted to verify why the answer was 7 there. Okay, so that's that there. Next, let's go C to D. C to D, so that would be, I'm going to go in the order of 5. Whoops. For C to D, 5 minus 3, that gives me absolute value of 2, which is also regular 2. And but as far as the units go, you can just put U for units. Technically, we need a unit there, but they didn't give us any. All right, and then from D to A, I'm going to go in the order of 5 minus -4. You could also go -4 minus 5. You should get, at the end, 9. And then you can put 9 units right there.